All right, we are live on YouTube, and we'll be getting started in just a few minutes.
Great.
All right, Tim, it is 6 o'clock on the button. Ready to get started?
Ready?
Excellent. I'll go ahead and start the recording.
This conference will now be recorded.
Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# User Group. A little bit about the group. We meet every month, typically every fourth week. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find all the meeting information for past as well as future events posted on meetup.com at the link listed at the bottom of the slide. As always, a big thank you to our sponsors, the .NET Foundation for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space as well as the recording. If you're joining us for the first time, first and foremost, please keep in mind participation is encouraged. We're open to all expertise levels, whether you're a student, a hobbyist, or a working professional. And like I always say, the only stupid question is the one not being asked. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, meaning feel free to jump in with any questions or comments, but at the same time, we want to give our presenter enough time to go through the slides and the demos. And lastly, the meeting is being recorded and will be posted on YouTube with the link provided shortly after the presentation in the chat window. So for tonight's feature presentation, we have C# game development with Unity, presented by Tim Corey. Tim joins us from the Dallas-Fort Worth area. He has over 25 years in professional software development experience. He's also a 9-time Microsoft MVP. And he does a great deal of training at IamTimCorey.com, where he has literally taught hundreds of thousands of students and working professionals how to be better software developers. And so with that, welcome, Tim. Glad to have you.
Thanks for having me.
All right, I'll make you presenter, and the floor is yours.
Great. So I am going to jump right in here. Thanks for having me. I haven't been to the Cleveland area in a while, but I used to frequent there. Actually, the first time that I spoke, I believe, in front of a group was in Cleveland. I think it's actually where I met you, Sam. But yeah, it's good to be back. So what we're going to do today is, I'm not big on slides. I'm not big on, theory. What I'm big on is let's get our hands dirty on something and try something out. So what we're going to do is we're going to start from, just learning about what Unity is and how it works and how we can apply, if you have it, C# knowledge to it. So that's what we're going to do. We're going to jump right in and, start from the ground up. So Unity.com is where I'm at right now. And if you probably not a great idea to follow along right now, just because of the fact that Unity can take a little bit of time sometimes. But if you're watching this video later, this replay later, it's a great time to pause and download and set things up and try things out for yourself. I'm a big fan of practice, because whenever you watch a presentation like this, what happens is you watch it and you go, oh, that's obvious. Got it. And then you go to do it and you're like, I don't remember how to do that. So I encourage you to, pause the video later, practice it and try it out. It's because this is both a lot of fun, but it'll also grow your skills both in C# and also in being creative. If you do C# for a day job, this will really help apply your skills in a new way and kind of grow your skills in C#. It's a little different. If you're not familiar with C#, this is a great way to get started. It won't be the everything you need to be a developer who's not working in games, but it'll give you a good start in that. So let's jump right in. We'll walk through this, step by step. I'll do some things and I'll explain why we're doing those things, and you can kind of see the pitfalls to avoid and the best practices to follow. So Unity.com, we're gonna go to the download tab, and just here, download the Unity Hub. That's really all you need to know how to do is download the hub. If you're on Mac or on Linux, you can do the same thing, just on your platform of choice. Okay. Now you'll also want to create an account on Unity. That gives you a free license. And it also allows you, if you were to buy assets in the asset store, you can keep them in your account, and then it connects right up with your hub. Now, I will say this. If you are considering trying out Unity, if you've never done it before, don't buy assets. Don't buy stuff. Learn how to do it first. In fact, I'm teaching a game development master course right now. And, we've gone through 10 sections of content, like 40 or 50 hours of content. And what we've done so far is kind of built up. And only recently we started to use somebody else's assets. But I really encourage you to start with the basics, start understanding the fundamentals. Otherwise, what happens is you get so focused on, does this look pretty, that you never actually make something that works or that gets deployed or that's even a valid game, as in it can do anything. So I would encourage you, don't start with assets. In fact, in this session, we're not going to deal with making things look pretty. So we're going to have squares and rectangles and triangles and circles. And we're going to have a lot of kind of pretend. You're going to have to visualize, because this is about, working in Unity to understand how the game works and then how the code interacts with that game. Too many people get focused on the front end and making things look pretty. But if you're a developer, you know that the look pretty of an application is just the tip of the iceberg of what the full application is. So that's enough of my soapbox. Let's jump right into Unity. I have the hub installed, and I'm on a new project page. And what we're going to do here is there's lots of samples and different ways of doing things. And if your thought right here is, I'm going to create the next Call of Duty as my first game, let's skip that. Let's not do that. Instead, think about, what can I do to start? What can I start with? And I want to grow from there rather than starting with your perfect game in mind. It's just like software development. When you think of learning software development, you shouldn't think, oh, I need to start with the app I think is going to killer app. Don't start there. Start small. Otherwise, what happens is you never get enough practice in the fundamentals, and so you never really get confident in what you're doing. Okay, so what we're going to do is focus on Universal 2D Project. Okay, this is called the URP, or the Universal Render Pipeline 2D Project. Now, when you think 2D, you may think, man, I really want to do 3D. I recommend starting in 2D because of the fact that it's, well, one less D. You got one less dimension to worry about. And if you as a developer were, thinking when you started out, oh, there's a lot of math involved, and you realize there's not really a lot of math involved in creating, basic CRUD applications for a business. Yeah, well, in gaming, there is a lot of math involved. And the math from 2D to 3D can get a little more intense. These are, again, 3 dimensions. However, when you learn in 2D, you're actually working with 3D. It's just that you don't really use the 3rd dimension as much. So just note you're not losing anything by doing 2D. Okay, so you can also pop it out, by the way, if you wanted to. You can even do a Paper Mario kind of thing, but that's a little beyond the scope of this demonstration. So 2D, we're going to choose the LTS version of 6.0, which is actually, it's 6,000, but it's actually Unity 6. So organization name, my project name, we'll give it Cleveland User Group. Sounds good. And I'll put it in demos. I'm not going to use version control for this, but just know you can use Unity version control. That's really good at dealing with, especially those large files. When it comes to games, you got a lot of large files, and you got a lot of binaries, and you got a lot of things that are more difficult to deal with compared to just using Git. But Unity version control does a good job for you. So create project. This will take a bit. So you're gonna get this dialog right here. I'll move this off the screen. And this little thing here is going to take a while. Don't worry, it's not your computer is slow. It's Unity that's taking a long time to build things up. So don't panic. Yeah, it's getting slow the first time to load. And in fact, loading new projects takes a bit too. There's a lot of stuff getting put in memory. That's okay. Let it do its thing. This is kind of like, Visual Studio, where, people say, well, it takes up so much space on my computer and it's so, bloated. I disagree with that sentiment, because of the fact that this is designed to build, in this case, full games. In the case of Visual Studio, it's full applications. It's the primary thing you're doing on your computer, if that's your job. So it's going to be a bit big because it's going to have a lot of tools inside of it. As we see when you open this up, there's a lot of tools inside of Unity. And that's one of the things I want to show you today, is how to navigate this, because there's a lot of stuff. And if I don't want you to get overwhelmed with a lot of stuff that's going on. So again, still running, but if you have questions, by the way, feel free to drop them in the chat. I think Sam's going to call now if he hears them. You're not going to disrupt me if you have a question. There's some questions that may be covering later, and I'll just tell you, hey, we're going to cover that in a little bit. Not a problem. But if you have something that might be relevant to this particular spot, then let's jump in. So it's still loading. It went to the other screen now. Just a minute while it finishes loading some scripts. Once it does that, I'll bring it back over to my main screen. So yeah, if you have any questions, again, shout them out. Okay. There we go. So this is Unity. This is what you're going to get when you first start off. And there have been a few updates to the package that I really like for getting started. One of the things that you'll see here is the input system down here. it is, here, let me turn my joystick back on. I know it says joystick reconnected. There we go. So one of the things I like with this input system is it's done for you. In my course, I teach you how to build this, but it can be a bit tricky. So for simple demos, it's great to have one pre-built for us. We're going to use that in a minute. So what we've got here is this square box represents our field of view when we run the game. This is the camera view. So you can actually zoom out here and see that it's, can be huge. You can zoom in and see, more than the view if you want. You can also right click and drag if you want. These little indicators on the left here are indicating the different tools you can have for moving things around. So you can have the little hand to drag things around with your left click, but I tend to use my right click to drag things around. Okay, so the first thing I want to do is I want to deal with these gizmos. I personally hate the gizmos. I hate these little icons here because they just get in the way. Now, they're not actually here in the scene view. The game view, this is what you would see if you actually played the game. You don't see them, but in the scene view, you see these gizmos. So up here in the upper right-hand corner is this Gizmos tab. Now, it has taken me some trial and error to find all of these, and you may find yourself checking and unchecking things, trying to find out which stupid gizmo is lighting up. You don't want to just turn them all off, because if you do, watch what happens. Cool, except where's my little box that indicates what the current camera view is? It's gone too. It's part of the gizmos. So we don't want that. But instead, what we're going to do is we're going to come down here to this built-in components and look at camera. And notice there's two things here. There's an icon and a checkbox. We're going to turn the icon off, and that takes the camera icon away. That's one. So we also want to look for the Light 2D, which is, I believe, up in this section, Light 2D. But notice there's no icon, so it's a checkbox. Now watch again in the middle here. When we check Light 2D, away goes that little globe thing. And finally, this one drove me nuts. There is a tiny little camera. It goes away if you zoom in too much, but I can trick it right there. Again, drove me nuts. So what we're going to do is go back to Gizmos, and we're going to look for Universal Additional Camera. So that's down here, Universal Additional Camera. Uncheck that, that goes away. Hey, we're good. So that's one little tweak that I love to make whenever I start a new Unity project. Okay, so let's jump right in and look at what we've got here in our view, because there's lots of different things on this screen, and I'm doing everything on one screen. But I would encourage you, if you have two screens, use two screens, because it allows you to have a better field of view. So on the left here, I have the hierarchy. This is my sample scene. You can have multiple scenes. So for example, your intro menu might be a scene, and then the first level of your game might be a scene. The second level, the third level, and then the end credits might be a scene. So we're going to deal with just one scene, and that's this right here. We have, by default, a main camera and a global light. Now notice this little icon popped up here. That's because we've got the move tool selected. But what this allows us to do is have something to watch the game. That's the main camera. And the global light 2D allows us to illuminate the game. So by default, we have those two. If you want to have like a camera that tracks the player and moves along with them, and if they jump, it moves up a little bit, but not the full way, and all that kind of stuff, you probably want to go beyond the normal camera built into Unity and use something like Cinemachine's camera. If you're into photography or into movie making, while there's basically the same amount of control that you'd have with a real camera, but in Unity. So you can do all kinds of crazy stuff with handing off to different cameras and panning and tilting and zooming and all the rest of the stuff you want to do. We're going to keep it simple and just use the main camera. Same thing is true with light sources. You can add multiple light sources and have a directional light source that throws shadows and all the rest. we're going to leave it alone for right now. Okay, so let's go ahead and just set up a simple scene. What we're going to do is we're going to create a side scroller game. That's it. Okay, and we're not going to move the camera. We're going to leave it alone. So I'm going to first create the ground because ground is important. So I'm going to create 2D object. I right-clicked, by the way, in my hierarchy. I'm going to create a 2D object, and I'm going to say sprite, and I'm going to say square. That creates a square for me. And I notice it's renamable. I'm not going to name it yet. I'm going to rename it in a minute. So this gives me a square. I can move it around using the move tool, the second tool here. And if I grab the blue box, I can move it wherever I want. If I grab the green arrow, I can only move it up and down. If I move left to right, nothing happens. This allows you to choose how you want to move something. Same to the red arrow. You can only move it horizontally, not vertically. Okay, so I'm going to move this down. Notice I'm moving it below my camera a bit and even to the left of my camera. Then I'm going to come over here and choose the rectangle tool. Actually, it's rect tool. I'm not sure it's rectangle. I always think rectangle, but it's RECT. But what this does, it gives me the points by which I can click and drag. So I can drag this out to the size I want. Now notice I can make this as big as I want or as small as I want. I'll make it like this and cover that bottom of the camera. So that allows me to resize this rectangle to whatever size I want. Now, on the right-hand side, so the left-hand side, we have our hierarchy, which has our main camera, our light 2D, and now a square. And that's just all one level right now. Well, on the right-hand side, whatever we have selected, in this case, square, we have our inspector. Now you can move these tabs around. You might find a different spot in your Unity where it might not even be open, in which case it's just like Visual Studio, if you're familiar, where you go and find that view to open that up. But in the inspector, this is inspecting or the properties of one object. In this case, this white square here. So the first thing you see is called a square. Well, I can rename that. Let's rename it ground. And notice on the right-hand side now, our hierarchy, it says ground. Now it's got a position, and that's the X position, the Y position, the Z position. Remember, we're 2D, but we actually have a Z position. We have rotation, we have scale. So if you messed with any of these values, notice I can make it smaller or larger. Okay, I did that by grabbing next to over the X. And I got this little arrow here. I can click and hold and then make it smaller or larger as I want. The same is true with the Y direction. I could make it taller or smaller. So we get to play around with these things. And then also notice the positions change when I change where this is. Same thing with if I were to shrink it, it changed the scale in the X, it changed the scale in the Y, but also the positioning. So also notice Z is a scale of 1. Just want to point this out real quick. If I were to click this 2D up here at the top, I untoggle 2D. Notice now we're actually in 3D space. So we can move around here and see that this is actually just a really thin 2D object. If I toggle 2D back on, now you can see we're back into 2D mode. So you could, in theory, make things 3D, but only show 2D. You can also do things like put things in front of or behind something else, and that will show up, and that's that Z index. So you can stack things, have things in the background or the foreground, and it still be 2D. Okay, next up, this square, we're going to change this color. I'm going to click on this white color here, and let's just give it a green. Not neon, but something like that. So now if we come over here, that we've changed the color, and notice it's kind of gray in the background, but if we go to the game tab up here, this is what you'll see in the game, or something similar to it. We have a blue sky, that's the default, and then we have green at the bottom. Sounds about right. Let's just move up that green a bit because I want to show a bit more of it. Let's actually get the move tool here and drag it up like so. So now there's our green grass at the bottom, and we have our blue sky in the background. Now, if I were being a little more creative, I could put clouds in the sky and mountains in the background, or use good assets to make things look a lot prettier. And And, as a non-designer, assets are my saving grace when it comes to making good looking games. But again, I want you to focus first on making the game fun, and then you can worry about making it look good. Okay, so if you ever go to manipulate something, you're like, why can't I grab this? Why can't I change this? Make sure you're not in game mode, because game mode is for looking at it, not for manipulating it. You want to go back to scene view in order to manipulate it. Okay, so I have this ground here. What I'm going to do is I'm going to add one thing to the ground. This is where you get add component here in the inspector when you're selecting the ground object. I want to add component, and I want to add a box collider 2D. Remember, we're in 2 dimensions, therefore box collider 2D. So what does a box collider 2D do? Well, what it does is it allows for collisions, so that when one thing touches another thing, they don't go through or pass by each other, but they actually stop and hit each other. So this box collider 2D is going to, by default, just follow the shape of the box, because it's a box collider. There's other kinds of colliders like polygon collider and circle collider and so on. But if you notice the edit collider button here, you can select that. And if you notice here, you'll see these like green points that are on the edges. That indicates where the collider is, like where the boundaries of it are, because it actually is a light green box surrounding this dark green box. And that's the actual collider. Okay, so that's all we have to do. Notice you've added a sprite renderer that actually renders the thing on the screen, and that gives it the color. We can also use something else instead of a sprite render. We can actually add images or something else, but for now we're just going to use a color. And then we've added one more component, and that is a box collider 2D. So now we can collide with this object. Okay, so we now have everything we need for our ground. That's it. Now let's add a player. So you're going to right click. We're going to say 2D object, sprite. We're going to add yet another square. And this time we'll call it player. And notice it over here in the inspector, it renames it player. And notice that sprite render is here but collapsed. I collapsed it previously. So just don't miss that it's actually there. Let's change our color here of a person. Let's go in the red hue somewhere like that maybe. And then we're going to resize this like so. And then we're going to grab the movement here and move it over here. Now, let's put it up high for a minute. And if we look at our game view, that's what it looks like. This little rectangle here is going to represent our player. So this is what we'll use to move around, etc. Let's actually make him a little taller. There. Cool. You're not going to get great graphics from me right now. This is going to be about the gameplay itself. So we need to add a few things to our player. Let's collapse down sprite renderer, because we're good there, in order to make the player interactable with the environment. One of the things is, again, that box collider 2D. We want to make sure it have collisions with other things. We can leave that alone. We can even collapse that. We're going to add one more thing, though, and that is that we want to add a rigid body 2D. So what rigid body 2D does is it applies physics to our object. And this is one of countless reasons why using something like Unity is such a good idea. Because Unity provides all of this pre-done work. We're building on the shoulders of an existing game engine. You could create your own game engine. There's a lot of work involved, because you essentially have to replicate everything you see on a screen. And as you notice, there's a lot of stuff already on the screen, and we have 2 shapes. That's it. And there's a lot of stuff on the screen. So I would encourage you to think about not just reinventing the wheel. Start with Unity and go from there, because there's an awful lot of stuff that is done for you. In this case, rigid body 2D allows us to apply gravity. So by default, we have a mass of 1, we have a gravity scale of 1. Let's just focus on those two things. So how massive it is, how much mass it has, and then how much the gravity scale is. By default, it tries to apply a general gravity scale. And if you see, right now we're hovering in air because we're not playing the game yet. But let's play the game. Notice where it is right now in this view. We're going to hit the play button, wait for it to build everything. And my joystick disconnected. That's okay. We'll connect it when it's time. Now I haven't hooked up any controls yet, so we can't actually move the character. So there's no movement available except for the fact that character just dropped. You notice that? It just dropped down to the grass. Why? Because gravity applies. But yet our grass didn't fall because we don't have the rigid body 2D, the ability to interact with gravity. We don't have that on the grass because we don't want that. Otherwise, the grass would fall down and it would fall outside the scene. It would just keep going. Notice that the little player's on the grass now because we're currently running. But if I hit stop, it goes back and the player's back up top. So if we were to apply a rigid body here, then the grass would fall too. We wouldn't want that. Let's just watch it just for fun. Let's just move this grass over for a minute. And we're going to run this again and watch. And we come back over here. You can actually see if we can get, there it is. There it is. There's my player. It's hard to see, but it keeps falling forever. Okay. We don't want that. So we want to make sure that we put our player on something like so that when they fall, if they fall, and we're going to bring them back to the ground, but if they fall onto something that has a collider. So it stops. This also means that when we actually add controls to this, we could drive our player off the cliff. We'll talk about that in a minute. So we now have our player set up. We now need to add some input. To do this, we need to add a component to our player. Make sure your player is selected. We're going to add a component, and we're going to say player input. Now, because the fact that this default project already has the input system set up, it applies to our player automatically. We don't have to actually drag it over. If you create your own or did not have this input system control already there and you create it later, you would drag this onto this actions spot and it would take care of everything else. Now, there's a lot that goes in the input system. I have a lot of content already on the input system because of the fact that there are 4 different ways you can do the input system. You want to send messages, broadcast messages, invoke Unity events, or invoke C# events. And then based on which one you do determines what kind of code you write. There's a lot to it. We're not going to get into it. Basically, though, we're going to use the basic send messages system for this demo. Now, notice you have another gizmo. So let's get rid of the gizmo. So we go to gizmos. We look for player input, not player input manager, player input, and uncheck the icon. Icon goes away. Okay, so now what we're going to do is open up the player input system to see what's in there. So double click on it. And what this shows us is we have a move, a look, attack, interact, crouch, all the rest. So this is the basics of what you'd want for an interaction system for a game. Move, look, interact, attack. And jump. Those are the big ones for a platformer, for a side scroller, for things of that nature. And if you expand out, you'll see that we have the left stick on a gamepad. So a gamepad would be something like a Xbox controller. I have one at my desk just for playing around with games I build. You also have the keyboard, which is the WASD keys. That's default. You have the primary axis or the stick on a controller. So there's lots of different ways that you can interact with this system, and you can create code that says, okay, you can do this way with one and one, something else with another. But the really cool thing is we're going to focus in on the move command and the jump command. We're not going to care if they hit a key on the keyboard or use a joystick or a gamepad or something else that is in this system. Why is that such a benefit? Well, because we don't really care how you want to how you give us the input, as long as you say this input is movement. Because how many of us have reconfigured controls in a game? Probably a lot of us. If you haven't, you're not living. Yes, there's some defaults, but there's a lot of things you can do to kind of tweak your game to make you better by just changing the layout. Or maybe there's an accessibility thing where you don't have full control of your left hand, but you have full control of your right hand. So you swap things around, or whatever the case may be. You don't want to have to go in and change code in order to allow that to happen. You don't want to ship a new game because somebody else wanted a new control system. That's not how you want to do things. And so what you want to do is, using this new input system, you just talk about the move and the jump and the crouch and the attack and the look. So that way it can be remapped dynamically at runtime per person. So I just want to point this out because Unity didn't used to have this. There's an old way of doing things and a new way of doing things. And if you see demos out there, if you see examples out there, you may see the older way of doing things, which includes people saying, okay, if they hit the D key, do this. Well, that's great as long as no one changes or remaps what they want the D key to do. So therefore, this is much superior. It was totally redone for, I believe it was in preview in the previous Unity, and now in Unity 6 it's default. So it's been around for a while. It's been battle tested. It works great. So just know that is here. Also note that you can have different action maps based upon different parts of your game. So you might have a different way of interacting for your user interface than you do for the player. An example of this might be, with your controller, you might use the left stick to look around. And yet when you're in the menu, you want the left stick to move up and down the options. So therefore, you might have two different action maps based upon which place the player is in. The same thing might be true if you're playing a game where maybe it's a first-person shooter game where you can jump into different vehicles. Well, when you are just running around with a gun, then you want to have a certain set of controls. But when you jump into a vehicle, now you're driving something. That's a totally different set of controls. That's where different action maps can be really helpful. In code, you can say, let's switch over to a different action map now that this event has happened. So this new input system has a lot of depth. There's a lot of stuff you can go through and learn about. But the good thing is that it really separates out the which specific control is hit from the action that you want to perform. That way you can code against the actions and then change dynamically, or the user can change whenever they want the specific control that triggers that action. All right, so this is already done for us, which is awesome. Makes demos like this a lot quicker for me to do, which is great. So I'm not going to say that I didn't change anything. Okay, so now what we need to do is we need to connect the dots, right? So we've got the player, and the player has the player input. You might think, well, now we're done, right? Well, no, because we've got the player knows that something's happening. That's the player input system. And it fires events when something happens, but there's nothing listening for those events. This is where we write our code. Our code comes in primarily around events, things that are happening in the system. So that's where we write a bit of code. And to do that, what we're going to do is, there's different ways of doing this. You could select a player and say add component, and then type script, and then down at the bottom there's new script, and then you type the name, etc. Personally, what I like to do instead is I like to right click here and say right click in the assets section. Notice that down here in assets, we have the input system, the universal render pipeline for global settings, and the default volume profile. These are things that come with the game by default, but there's other things in here. For example, the sample scene, which that's what we're in right now. Remember, we can have multiple scenes. There's also settings in here for other things as well. This is where you put all the things, all the assets that you are creating and manipulating. This will get super full. You're going to have lots of stuff in here. And at first, what you're going to do is just dump everything in this assets folder. And I encourage you to do that because you don't need to over organize before you're ready. But when it's time, you can create folders and start putting things into folders as it makes sense for your particular way of doing things. So I'm going to right click in here and say create. And then down here under scripting, notice there's a lot of stuff you can create, a lot of different assets. But we're going to go to scripting. And then there's different types of scripts you can add. Model behavior script is the default one typically you want to add. There's also scriptable object or empty C# script or playables, etc. What they're doing is basically just a little bit different template. That's it. So you don't have to worry about, which script do I do? Do I get the right script? Just do everything as model behavior. You're cool. You're good. Because you can always delete the stuff and it's an empty script now. And if you create an empty script, well, then you might forget, how do I do that default stuff? This way, model behavior script, it gives you the default stuff you need. Let's call this player script. Now, I'm being very generic here because the fact that we're going to create one script for the entire player. But there is something where you might want to create multiple scripts for a player. And so you might want to call this player controls as opposed to player information or something else. It all depends on how big and complicated your project gets. Again, just like the assets folder, I would encourage you to start with one script. And then if you find, hey, I kind of need a second one, then go ahead and separate things out. But don't try and create this multiple layers. Let's apply interfaces and all the rest of the stuff like we do in C# coding. Don't go there yet. Try and keep things simple. The KISS principle. Keep it as simple and clean as possible, especially when you're learning. But even afterwards, you don't want to add complexity to the system when you don't really need it. So we now have a player script, and notice because I've got this selected, on the right here under the inspector, you can actually read the code. So if we look here, this is the code for the script right here. That's what's by default in that model behavior script. What are the big deals here? One, it inherits from model behavior. It brings some things along with it. And then it has two methods that are here that are events. So first is start. This happens once. Notice the nice little comments here to help you out. It happens once before the first execution of update and after the model behavior is created. So this is the initialization spot for most things. Now there's another one that you might eventually get to as well for other times that maybe before other things are there's so much stuff going on, but we're gonna keep it simple. Start. It's when the object is first created. Now, for us, the object's on the screen already, therefore that's at the beginning of the game, at startup. You can create objects during the game's life cycle. So you can create things that appear. And that would, when they appear, is when that start would run, not at the start of the game. And then we have this void update method. And the update method is going to run once per frame. And what is a frame? Well, a frame is one re-render of your game. Now, if you're a gamer, you probably have dealt with FPS. You always want to have good FPS. You want to get a computer that can run this at 100 FPS or 200 FPS or some crazy FPS. FPS stands for frames per second. So when you think about that, this method right here, update, is called once per frame. So when you think about a game running at 60 FPS, that means that update has been called 60 times in 1 second. This is where you need to think about performance. As developers, if you deal with like business C# and you deal with writing code for a business or for work or something like that, we deal with performance, but we don't overly concern ourselves with performance. Yes, we want to make apps that are performant, but growing up, I grew up in the time when it was basic and it was, computers had very little RAM, and so everything is about saving a cycle, saving 2 cycles. And if you look at the original Mario game, Super Mario Brothers, I believe it was in the kilobytes. That game was like 30 kilobytes or something like that. If you look at the game, you'll see they reuse like bushes are actually clouds, and there's different color. Well, that's because they're trying to cram as much as they could into as little as possible. They didn't have a lot of RAM to deal with, not a lot of processor to deal with. Just like with normal development, with business development, games have benefited from faster computers with more RAM, with more resources available to do more stuff. So yes, you can run your games at a faster FPS now than you ever could in the past. But you still want to be very, very cautious about how you do things in Unity, because a lot of what we're going to do is going to focus on this method right here. Okay, so that method, update, is going to do a lot of work for us, and it's going to run potentially over 100 times in a second, 1 second, which means, again, if you were a line of business developer, you wouldn't want to call a data access here. You wouldn't want to go to a database, because it'd be kind of cool to have database access in your game, right? Yeah, but 100 times a second, that's going to be a little much. Let's not do that. Let's rethink how we go to the database. Let's rethink how we get data, because yes, we're going to deal with data, not in this demo, but in a game. And we're going to store data somewhere, a database like Spot, but we're not going to put it in the update statement. We're not going to instantiate new things over and over again in the update statement if we can help it, because all this will add to the overhead of our game, make it slower, and slow down our FPS potential, because it may run at 60 FPS still on your machine, which is a development machine, which might be very fast. But when you install it, or someone downloads your game and they install it on a laptop from 10 years ago and they try and run it and it runs at 5 FPS, that's not a great experience. And they're going to give you a bad review, because they're going to say your game is so slow. There's a reason why. So when you think about coding, you're going to have to be very conscious about, is this expensive code or is this cheap code? Is there a better way of doing this than just putting it in the update statement, or is this the right place to put it? Okay, so that's our code. That's the default for a model behavior script. If you had a empty script, it would just be the class name. You'd have to inherit from model behavior by yourself. So I moved my camera, it looks like. There we go. Camera move back. So what we're going to do is we're going to edit this script. Before I do, though, I do want to show you, if we go to edit and then down here to preferences, not project settings, because this is a preference for all of Unity, not just for this particular project. Preferences, in here's a whole bunch of settings about Unity. And you can change a lot of stuff, but under external tools, you will see, you might come in under general, but come down here to external tools. Under external tools, you'll see external script editor. Again, we can zoom in here. External editor is right now for me Visual Studio Code. Okay, so you have, for me, because I have all three installed, I have VS Code, I have Visual Studio 2022, and I also have Writer. So you could install any of those. You can have those installed on your machine and then use those with Unity. For me, I use VS Code because of the fact that it works on Windows, Mac, and Linux. And again, I'm creating a course on this, so I'll make sure I do things that are cross-platform. If you're looking at this and you're on a Mac, well, then you wouldn't have access to, you can't install Visual Studio 2022. Therefore, at most, you can have access to VS Code or Writer. Again, with Linux, same thing. So this is based upon what's installed on your computer. Now, when you first install Unity, it might say, hey, do you want to install VS Code? You don't have to. You can just say, no, I don't want to do that. I want to do it later. I already have it installed. And you can just install the plugin for Unity later. But for me, I have all three options. I'm going to use VS Code for this demo because, again, it's what I use all the time. It's cross-platform, which means that it'll work the same way or close to the same way on all three platforms. So you don't have to worry about it. So again, edit, preferences, and then external tools. You can change that to whatever you like. Which means now I can double-click on Player Script, and I can open that up in a new window. So this is my VS Code. And what it has done is it has opened up my Player Script. In fact, let's just, we'll make that font a little larger. So this is what you saw in that preview window. But just here's a quick tip. Whenever you make a change in here and then go back and click on Unity, it's going to recompile. Now, it didn't compile here because I didn't make a change, but it's going to recompile. And so it's going to take a bit of time. So what I would encourage you to do is try and make your changes in a group and then go back to Unity. Otherwise, you're going to spend some time waiting for that recompile. There are tips out there. I have seen people share tips on how you can have Unity not do that recompile. I would encourage you, don't do that, because what it's doing is it's rebuilding it so that you can have the latest scripts available when you run your application. And if you try and turn that off, what ends up happening is you end up having old versions of code that are still running and still operating. And so you think that you didn't do something right when you did, but just hasn't recompiled yet, so you didn't know, and just creates a mess. So maybe don't do that. Maybe just leave it like this and don't worry about the recompiling. Just take your time. Also note, when I first added this, I was talking and I didn't catch it in time to show you. When I first added a script, Unity recompiled. Now, when it recompiled, that's a good thing because I'm going to put this script on the player. Right now, it's not here yet. But if it has not yet recompiled after I create the new script, then you go to click and drag it, it won't work. So just know you have to make sure that wait a second or two for Unity to catch up that, oh yeah, it's a new script, and I'll recompile. Then you can click and drag. That's why I typically will modify a script first and then come back and click and drag. Here's what I always forget. And I actually, in my course, a couple times, I do it on screen because it just happens. I will modify a script. I'll make the changes. I'll go and I'll hit the run and nothing will work. And I'll be like, why doesn't this work? And the answer is I never connected the script to the object. You need to do that. So let's just do this right now. I'm on player. I'm going to click and drag the player script. So don't click and let go, because if you click and let go, well, now the inspector is for the player script. Click on the player again, click and drag the player script and drag it into this open area here. That adds a component called script. And it's named specifically player script because that's the script that we just added. So you could also add the script manually and then drag and drop a script on. I just find this is the easiest way that for me to add the script and connect that. So now the player has a script attached. So those two things are connected. That means we can start doing coding that will affect the player. And also in this case, the player can affect the code or the controller. So when I hit the right on my joystick, my right joystick, I hit the right direction, then the player is going to get the move command in that direction. So let's start writing code. Okay, now we are going to need to do a few things in here. One of the things we're going to do is we're going to come up to the top. So this is outside, this is in the class, but outside of any methods. So this is global to the class. We're going to create two fields. So we're going to create a private float move speed. And I'll start that off at 5F, and a private float jump force. And we'll start that off at 10F. Now, again, if you've watched tutorials, especially tutorials where the person comes from a design background, this is one of the reasons why I created this course, because people come from a design background and create games. And they're beautiful games, and they do work. But when it gets to the code, they're like, oh, I copied and pasted this, and this works. I copied and pasted this, and this works. I write this code this way. I don't know why it works, but it does. I don't love that, because your whole foundation of your game is built on your code. And if you don't know why your code works, you don't know why it breaks. So let's go ahead and understand why our code works or doesn't. So if you're a developer, you know a bit more about public and private. But essentially, you want your class to be public because you want other classes to be able to access this class. But your variables here, the fields, you don't want those to be public, because then anybody can interact with them. So anybody that has access to an instance of player script can change a value even if they're not inside a player script. So what happens is you could have a weapon or an object in the game tell you that your move speed has changed, and it would just do it. And then all of a sudden you're like, why is my movement speed changing? And you look in this code here and you can't find where it's changing. You're pulling your hair out. And this is my problem. And the end result is, oh, it's changed somewhere else. I didn't know. And if you have 100 scripts, 200 scripts, it's really hard to track down what changed your movement speed or your jump force. So keep them private. But the reason people make them public is because they want to change them in the Unity editor. So let's just make them public temporarily. And I'll show you why. So if we save this, and I just drag this off and I come back over here and click, notice it recompiles because we've changed code. Once it recompiles, watch the player script area. It takes a bit. This is why people try and turn it off. You don't want to turn it off. But when you do, now notice that we have two new things here. We have movement speed and jump force. We have 5 and 10. So it took from that script that information. This is the variable name, but notice it says move speed when our actual variable was called move speed, all one word. Notice you look right here, it's move speed. Well, Unity is smart enough to go, oh, that's the convention for how to name something. So what I'm going to do is interpret that into what a normal would understand, a person who's not necessarily a coder. And so we're going to call it move speed. So that's why people make it public, because it's available then in the editor. But there's a different way of doing this, a better way of doing this. So we make this, let's just undo this. And again, if we undo this, we recompile. I know it's going to take a bit, but I want to show you this. Watch what happens to the move speed. It goes away because it's private now, which means it's not accessible outside of this class, except for the fact that we can come here and we can say on top of move speed, we can say serialize field. This is the magic. So I've serialized both of these fields. They're still private, but with this tag on top of them, I have now told Unity, yes, I know they're private, but for the editor only, I want you to still give access. So the editor will have access to those objects. Let's come back over here, recompile. We'll see that they come back even though they are private because they've been marked as serialized fields. There we go. There's our movement speed and jump force back again. So serialized field is the way to go. Now, there's one more thing that is a really fun little addition. Above both of these variables, I'm going to put another square brackets. I'm going to say header. And then in here, I'm going to say movement settings. And what this will do is when we come back over here, we're going to watch what happens to this area right here when I recompile, because I want to group these things in my editor. Notice it says movement settings now, and it kind of groups them. I can have separate groups now for my different parts of my data that I want to bring in with this script. It allows us to organize things a bit better. Kind of fun. Okay, so now let's get to the actual kind of code of this and understand what we're doing. We have two variables here, movement speed and jump force. This is how fast we move and then how much force we apply when we jump. Okay, now they're both float values. If you're working in Unity, get used to float because floating point numbers are what is used for most everything. If you're not a C# developer, a float is a decimal point number. It doesn't have to be. Notice we're just using 5 and 10. We put an F after to say this is a float. But it could also be 0.12345. It could be 6.12345, etc. Now, an integer can only be the whole number. It can only be 6. That's not precise enough for what we're doing in Unity. So therefore, we need a float. We don't want to use a decimal. That'd be way too expensive. So we instead use float. It's cheaper, and it gives us the precision we need without being too precise. It's too expensive. Okay, so now we've got our two variables here to determine how fast we move. For us, it's going to be horizontally. We're not going to worry about up and down. That's jumping, and that's the jump force. So we'll just move in the on the x-axis with our move, and we're going to jump with the jump key, and that will be in the y-axis. Now, what we want to do is we want to capture, we're going to put a separate section here, private. Really, everything should be private when it comes to fields in your class, unless you have a really good reason not to make it private. But start with private for everything if you can help it. So private, rigid body, 2D, we're going to call it RB. And we're going to say private vector2, and this is move input. Okay, so this rigid body we're going to capture actually in our start. Remember, start happens once before the first execution. And we're going to say RB equals get component, and we're going to say we want the component rigid body 2D. Now, where is this coming from? Well, this script is attached to the player object. So at the start, it's going to get the component rigid body on the player input. So it's going to look for the player input, and I'm not going to click on it because I want to recompile. But notice that on the right-hand side here, we have rigid body 2D. That's one of the things we applied to our player. That's the thing that gave us physics. Well, we're going to look for that, and we're going to put this in a variable called RB. We're going to have access to it. The reason we're doing this in start is we want to get the instance of that once. We don't want to get the instance every single time. That would be expensive. But if we do it on start, the instance doesn't change. Therefore, we only need to gather it once. And because it's an instance, it's not using up extra memory to grab the reference to it. So therefore, we grab that and put it in here. Again, this is object-oriented programming in C#. That's what we're dealing with. Okay, so now we have the rigid body. Now we're ready to do let's start with the events. So we're going to say public void on move. And thank you for the change there, Unity. Public void on move, we're going to say input value, and we're going to say value. And in here, we're going to say move input. That's this right here, vector 2. Move input equals value dot get vector 2. That's it. So what is this? Well, this is an event. This is actually an event handler. Again, if you're familiar with C# with object-oriented programming, we have events and event handlers. Well, the player input system that's attached to our player is going to trigger some events. And our script can listen for those events. And so we create the listener for the on move. Now, you don't need to wire this up. It's already wired up. So you don't have to say, event plus equals on move. It's already taken care of for us. But we're going to be listening for the on move event. Where did that come from? Well, if you go back, and I don't want to click on it. I'm going to click on it. Sorry. We're going to recompile. It is what it is. This is the kind of stuff you're going to deal with a bit in Unity. You're going to be like, oh, I want to go back and look at this. It takes a little bit of time. Not a big deal. So we have our player here. And if you go to the player input, and if we zoom in here, whoops, I was mousing over it. So there we go. So you will send message to game object on device lost, and then right here on move, on look, on attack, on interact, etc. Where did those come from? Is that just built into Unity? No, it's actually not. It is something that is generated. How is it generated? Well, let's open up the input system. We have, and this sounds familiar, we have move, look, attack, interact, crouch. So what happened is Unity said, oh, your command is move. I'll create an event called onMove. So onMove happens when you fire the move action. OnLook fires when you do the look action. OnAttack fires when you do the attack action, etc. So that's how it creates these events. So if you're looking for what events do I have, well, there they are. So onSprint is one of your inputs. Now, while we're here, I want to point out that the move is actually a vector 2 control type. So what it's doing is giving us movement in 2 directions. So it's giving us either the X direction and the Y direction at the same time. It's a vector 2. Now, vector 3 would be all 3 directions. We're dealing with vector 2. Okay, so that is why we have like the WASD. So the W key goes the up, the down is the S, the left is the A, and the right is the D, etc. A gamepad just provides a 0 to 1 value, actually a -1 to +1 in all, in X and Y. So that gives us the result of a vector 2. So we get the vector 2 from the value. So the value is the input value we were given on the move. So when the move fired, we get an input value. We're going to say, hey, give me the vector 2 for that movement. And that we're putting into this private vector 2. That's all we're doing. We're just, whenever that move happens, we're capturing the input that it gives us and passing it up here. And the vector 2 essentially has an X and a Y, and it says the X value is this, the Y value is that. That's pretty much it. So that's where I capture on our movement. Now, we need to do something with that. And that's where we're going to come into the update method. The update method is called once per frame, which means this is going to run over and over and over again. There's a couple different ways you can do movement. So you can do movement with linear velocity, meaning basically off and on, or you can do movement with a force, applying a force to an object. Remember, we have gravity and mass for our player. So we can apply a force to that player and say this force is applied to the player, and that should move them forward or backwards or up or down. So you can do either one. The applying the force is often the more precise one, but it's also the much more finicky one. In my course, we spent a lot of time tweaking that information. For a side-scroller platformer, it's often easier to apply linear velocity because linear velocity is just go. Whereas force says, hey, we're going to start off. This is where we get the slow movement that speeds up over time and it hits a top speed at some point, etc. That's a lot more to deal with when it comes to your calculations and a lot more math involved. But again, it can be the right way of going, especially in certain circumstances. But if you just want the start-stop kind of thing, then linear velocity is fine. The other benefit of linear velocity is you don't have to deal with delta time. We'll talk about delta time in just a minute. So we're going to apply linear velocity by saying RB, rigid body, dot linear velocity. And we're going to say equals new vector 2. And we're going to say the move input, which again is up here, that move input from when we did the on move, dot x times move speed. So we've multiplied the movement we're requesting in the x direction by this move speed variable, which right now is set to 5f. You might say, well, Tim, how do you know what 5 to set to 5f? I didn't. Just guess. Just throw a number in there. Make it small. Don't make it huge. But throw a number in there. Because remember, it's a serialized field. We can adjust this on the fly and figure out what works best and kind of dial it in while playing the game. So we're going to get to manipulating that in just a minute. So we're creating a new vector 2. We're not just applying the vector 2 we were given. We're taking a new vector 2 and saying, hey, I want to take the x movement direction. That's how much you want to move. I'm multiplying it by the move speed. So you can have a character that can move faster or slower. That way it's not locked into one particular speed. And then we're going to say RB dot linear velocity of the y. And we're not going to apply any kind of multiplication towards the y direction. That's because whatever direction, however much that player was moving in the y, we're not going to affect it. We're going to leave it alone. We're just worried about the x direction. We're not going to apply, if they move the up stick, we're not going to say, hey, I want you to float in the air somehow. We're not going to do that. We're just going to move left to right. This is a platform side scroller kind of thing. So therefore, we're just worried about left and right. So that's it for movement. That's all we have to do. Now, you may have seen demos where they deal with time.delta time. And they multiply everything by time.delta time. It's very important that you understand time.delta time. Very important. It's very important that you understand what this update method does. Because if you're not careful, then what you can do is make your game play differently depending on which machine it runs on. Remember that update runs once per frame. If your computer runs at 30 frames per second and mine runs at 60 frames per second, then I will have run this calculation twice for every once of yours. If you were to say move, let's just pick a simple example, move the character 1 foot to the right every frame. That'd be very fast, but let's just say we did. Now, if mine runs at 60 frames per second and yours runs at 30 frames per second, at the end of 1 second, your character would have gone 30 feet, mine would have gone 60 feet. That's not good. You want a consistent experience. So that's where we get time.delta time. And time.delta time, what it does is it says what percentage of a second are we running at. So really simplified example, there's a much better full example. There's like a 30-minute video on time.delta time. It's really great on YouTube. But what it does is it says, okay, if you're running at 60 frames per second, really simple example, then then time at delta time is going to be 1 divided by 60. So if you ran at 30 frames per second, it'd be 1 divided by 30. So therefore, we're going to multiply by time at delta time. That way, the end result is it makes mine moves it half as far. So let's just say that 30 frames per second is the goal. Therefore, it would move it 1 foot per frame. Whereas for me, at twice the speed, it would move it half a foot per frame. But I have twice as many frames. Therefore, it moves it at 1 foot or 30 feet per second. So it can get complicated, but this way with linear velocity, we don't have to deal with it because it's not going to change based upon the speed of the refresh. Just note there's also a separate method called fixed update that runs every 60 frames per second, regardless of how fast your computer runs. That's for something different. It's not for physics. We're dealing with physics-based stuff. But that would still need to deal with time at delta time sometimes because of the fact that there can be times where it skips frames or other things. You don't want your game running at different speeds on different computers. That's the bottom line here. Okay, we have movement taken care of. Now we want one more thing, and that's public void on jump. And we're not going to even pass anything into this because we just need to know that a jump command was called. And we're going to say RB for rigid body dot linear velocity equals new vector2 RB dot linear velocity dot x. And then for the y, we're going to say jump force. So what this is doing is saying, hey, I want you to set the linear velocity of the character to be the same as it was in the x direction. So if we're moving, cool, keep moving. If you're not moving, cool, don't move. But for the y direction, I want you to go up, apply it based upon this serialized field of jump force, which again, we chose a number of 10f, which f means floating point number. So that's just a number we chose. We can adjust that as we need to. But that's going to affect the y direction. This right here will affect the x direction. Now, a jump happens once. It's not something you put into update because you don't want to keep jumping and keep jumping and keep jumping every frame. You want to jump once. Now, what this is not doing, and I chose not to put this code in here because it would greatly increase the complexity of this demo, is this code is not dealing with multi-jump scenarios. It will allow a multiple jump. You can keep jumping all day long. You can jump right off the screen. We're not dealing with that. If we were, what we'd do is we'd say, hey, are you on the ground? If you're on the ground, yes, you can jump. And if you're not on the ground, no, you can't jump. That's a single jump scenario. Or we could say, are you on the ground? No. Have you already jumped twice? You're like, no, I only jumped once. Then go ahead and jump again. Or have you jumped twice? Yes. Well, then you can't jump anymore. That's a double jump scenario. Lots of different scenarios you can set up with more code and a bit more tweaks inside of Unity. But for now, we're just going to say, you know what? Let them jump as many times as they want, break the game. If we really want to, you put a roof on our world and not let them jump off screen. So we now have our on jump. That's all the code we're going to write tonight. But let's jump back into Unity. We're going to let it recompile. Notice there is a warning here. Actually, we have a little bit more code to write if we have time. But notice it's going to recompile here. And we have this warning down on the bottom that says, hey, player script.movement speed is assigned but never used. That should go away. It did. That's also under console. Here you can see any errors in your Unity editor. Okay, so now let's play our game. It's going to recompile all of our Unity project. When we do, I'm going to start my joystick because I like using my controller. I can use the keyboard as well if I want. But when we do, left stick allows me to move back and forth, left and right. I can also use the A button to jump. And that jump is pretty spectacular. Like I can jump off the screen in 2 jumps. And I just fell over. Why did I fall over? Well, I'm going to show you why. Because this is also something the first time you run this, you're like, what's going on here? Let's make that adjustment. So that adjustment, I'll actually add one object first to make it even more obvious. I wanted to wait until I did this, but we'll put it in now. I'm gonna put a triangle in. So I just right-clicked, I was a little fast. Right-click, 2D object, sprites, triangle. And I'm going to grab the edges here. I'm gonna make this triangle like so, and then let's go ahead and drop it down like so. Notice it goes behind the grass. You can change that based upon the Z order if you want, but right now it's fine. I'm gonna put this right here is fine. Okay, this will allow me to, let's add a component here. We're gonna add the, I get this wrong, the collider. And it's going to be the Polygon Collider 2D. If you're not sure, just type collider. You'll see all the colliders. You can even type collider 2D to limit them to just 2D objects. You can see that there's a whole bunch of different ones: box, capsule, circle, custom, edge collider, polygon collider, tile map collider. We're going to do polygon collider. And by default, this maps out to the triangle just fine. You could edit that if you wanted to. We won't need to. Okay, this allows things to collide with the triangle. If I didn't have this, they wouldn't collide. Let's go right past them. Now, let's run this again. And this time, I'm going to go up the edge and I fall over. And actually, we could have a fun little game here just by like trying to get the guy to land right side up now. Like, how long can you go before you flip him the right side up? Maybe it's not terribly interesting to anybody else, but to me, I have a lot of fun doing that. But why does the little guy fall over? Well, that's because we didn't make one change to our player. Let's change the player or choose a player, go to rigid body 2D, and under constraints, I want you to freeze the rotation in the Z axis. Okay? So this will keep the player upright. They will not fall either direction. Let's run this again. That little nugget right there can save you a lot of headache. So now you go up the triangle. Notice that it's a little weird because I've got this gap under me. Also notice I'm slowly falling down the triangle because gravity applies. So gravity is kind of pulling me down. But I can go up, I can balance on the point, I can come down the other side. Doesn't matter how I hit this thing, I'm not gonna fall over now because the Z axis is locked. This also brings up another thing though, and that is, notice that the movement speed here. What if I want to change that movement speed? Well, you might think, oh man, I gotta stop Unity, I've gotta go into the VS Code, I gotta change that value, I gotta recompile, I gotta come back in, I gotta run this thing, which is gonna compile it again a second time, and then I gotta try it out and go, nope, that's not quite right. No, you don't. Because when you're running, notice these properties over here. Notice we have movement speed and jump force. We can change those. Now, when you change them when it's running, they will only stay changed while the game is running. Once you get stopped, they revert back to default. So you can change whatever you want. Let's change the movement speed to, let's drag it up to 10. Notice again, I can select movement speed, click and hold, drag it a direction, or I can just come into the box and just type a value. But when I do, now notice the player moves much faster left to right. Cool. But this jumping is kind of floaty. First of all, it jumps way too high. I could change the jump force. I come down here and I could say, you know what, jump force is 3.5. And if I jump, now I'm much less. Okay, it's too little. So I can come up here and say, well, 4.6. Maybe, but again, we're still kind of floaty. Remember that under the rigid body 2D, this is where you applied gravity and mass. We can change the gravity. So let's just change the gravity to 4. Actually, let's just change it to 4. And now, if I jump, very quick, I want to come back up here and put 10 in my jump force. And if I do, okay, we've now got a much more responsive jump. That might be what I'm looking for, but it is going to affect the gravity of everything. We could play around and tweak these settings all you want and find the thing that works right for us. But that might be what I'm looking for. And again, I can kind of do multiple jumps to get up there, but it's a bit more solid. We land more of a thump. We could change the mass too if we wanted to adjust that as well. But that's how you can play the settings live. And notice that when I hit stop, the gravity is 1, the player speed is 5, the jump force is 10. We've reverted all those settings back. But if I come here to the gravity and say, let's change it back to 4, and let's change our movement speed to 8, well, now that's going to be the same when I run the game. Notice I clicked off that player. When I click off it, I can come back to it and click back on the object to see the properties when we run this. Real quick, come on, there we go. So back to player, there's still that value. It still has that kind of responsive feel to it, etc. So that's how you can change it in multiple spots because my code still says 5 and 10. It hasn't changed the code, but I've changed it in the front end. This is where you have to think through the different layers and say, is it okay I change it here versus in my code? I'd probably go back and change it in my code because I want that to be the default going forward. But changing the editor is just fine because that will save the value and it will apply to your player. Now, we've only got a few more minutes left, but I want to cover 2 quick things. So let's see if we can't get a couple things in real quick. 2D object, sprite, circle. And we're going to make this circle a little smaller because we don't want it to be massive. But by the way, we can control and use our mouse wheel to zoom in here. And then, again, right-click to click and drag. I'm going to do this. I'm going to let it fall right here. I'm going to apply 2 things. I want the collider, a circle collider 2D. And I want the rigid body 2D, which applies physics. Okay, and then let's change the sprite render to change that color. Something, sure, that works. When we do, what we're going to get is something that interacts with the world. Notice it fell, it rolled down the triangle, and it hit my player. And if I move, I can push it. And if I do, oh no, there it goes. It's off the screen. And it just fell. I haven't zoomed out far enough that you can see it fall. But we can do that with our object. The other thing I want to add is I want to add one more circle. And this is something that, again, you'll probably see a lot in games. Let's bring this down. We'll put it right about here. We're not low enough on the ground. This circle is going to hit it. We're going to change the color to yellow. And hey, you got a little coin. And I could have made it elongated, but circle's fine. We're going to add we're not going to add a rigid body, but we're going to add a circle collider 2D. And this allows for connection for people hitting it. But what I'm going to do is set this to is trigger. I'm not going to set this to be something that would stop something else. We're just going to trigger, which means things can pass through it, and that's okay. So if we were to run this real quick, we'd see that the ball runs through it. We're going to wait to do that. So now what I want to do is I want to add a script. So I'm going to say create. We're going to scripting, say model behavior script. We're going to say coin script. Again, keeping it simple. And we're putting it all in that same assets folder for now. You only have a few things. Later, I could just group them by putting folders in. There's the reload. Now we have a reload. I can come over here. I can drag my coin script onto my circle. So now my circle has a script. And then I can open up the coin script. Let's bring back our editor. And in this editor, I have done the model behavior script, but I don't want anything in here except for the inherit from model behavior. So I get rid of everything else. And instead, I'm going to say private void on trigger enter 2D, which, it does that. On trigger enter 2D. There we go. For whatever reason, Visual Studio Code is overriding and not letting us select things from IntelliSense. It's weird. But this is the structure for our event when a trigger happens. So I've said that coin is a trigger, not just a stop collision. So it's just going to say, hey, I was collided with. I'm going to say there's two things I want to do here. First off, I'm going to say, who did you talk to? Who collided with you? So I'm going to say debug.log. And debug.log writes out to our console. This allows you to do some quick debugging. If you're familiar with JavaScript, it's like console.log, which we all abuse. Or it's like console.writeline in Visual Studio for a console application that gives us a little bit of information. We can say, hey, I hit this, I didn't hit this, whatever. I'm going to say here string interpolation, so a $sign, and I will say the layer is, we'll talk about layers in just a minute, layer mask dot layer to name, and I'm going to say collision dot, and then we're going to say game object dot layer. So what this is going to do is it's going to grab this collision, and the collision says who attached to me, who touched me, and we're going to grab the game object, whatever touched me, and say what layer are you on. But then we're going to have an if statement. If, and we're going to say if collision.gameObject.layer equals layer mask dot name to layer is player. And if it is, destroy game object, which is essentially this. So destroy this coin. So what we're doing here is checking to see if the thing that touched the coin is on the player layer. And if it is, then destroy the object. So what we're saying is that if something hits the coin and it's not on the player layer, then don't do anything. But if it's on the player layer, then destroy the object. Essentially, it's like collecting coins. So that's all the code we need for our coin. Now let's come back over here and deal with layers real quick. So if we go to player, notice I didn't rename these. I should have, but time. So we have up here layers. Now, the way Unity does this is, let's add a layer here. Notice it has 0 to 31. That sounds familiar, right? This is binary. So what it's doing, I actually have a whole course on YouTube for free that's about binary, how to work with binary. And that came out of teaching Unity, because what it's doing is doing bit masks, and it's ones and zeros. And so you might have 0, 0, 0, 0, 0, 1, 0, 0, 0. And that means that particular one is true. And that's all we're doing here. So we're going to add a new one. We're going to call it player. That's on Unity layer 3 or bit number 4. So 0 is the first bit, second bit, third bit, fourth bit. So player. And we come back to player. And now we can, in this drop down, say the player is on the player layer. Now, this is where you want to make sure that you don't have a ton of layers. There's also tags. You can do that separately, but you can kind of group things on layers. So last quick demo, we're going to run this, and the ball is going to fall. Notice it's going to go through and hit the coin, go right past it. But if I push the ball, it goes through it again. But now if I hit the coin goes away. And if you go back to console, we will see that right down here, we have the layer is default. The layer is default. That was the ball hitting it twice, and the layer is player, and it went away. The coin object, notice, is gone from my sample scene. Now, if I hit stop, the coin comes back. That's circle 1. So that's how you would destroy objects. You could, do that, collecting coins, shooting things, interacting with things. I've given you all the kind of Lego building blocks to get started in Unity. That's the 5,000-foot overview real quick to get you started in Unity, get you doing something. My encouragement to you is that when you do this, that you don't try and create this huge, epic, massive thing. Create something small. The best thing about having not enough information about how everything in Unity works is you have real tight constraints. And the best games, the best movies, the best books all come from tight constraints. Whenever you see something that has unlimited budget, unlimited time, then you get a mess. You get something that never really gets pushed out to production. You want tight constraints that will spur on your creativity, and you can create some really cool stuff with just what I showed you tonight. Okay, so that's what I've got on Unity. I got lots more, but that's all I can do in an hour and a half. Thanks for watching, and I'll turn it back over to you, Sam.
Thanks, Tim. That was jam-packed with a lot of info. And wanted to pause for a second, see, does anyone have any questions? Also wanted to point out that there are 2 noteworthy comments in the chat. James Wood says, love your YouTube content.
Thanks,
And,
James.
Brandon seconds that motion. And I also follow up with another agreed to that comment as well. So
I appreciate it.
well done. Great presentation. Definitely a lot of great info. And if there are no questions or comments, what I'd like to do is go through a couple concluding slides. And let me go ahead and share my screen. In addition, I pasted a few links in the chat window. Pardon me. So the link for YouTube is posted in the chat window, and that is on my YouTube channel where the recording will be posted. If you would please subscribe to get upload notifications. In addition, excuse me, tech events are posted on my blog, samnasser.blogspot.com. And if you would please also subscribe to that to get the updates. And last but not least, the link for the feedback eval. Please take a moment to fill that out so we can provide Tim with some constructive criticism.
Fire away. Yeah.
Absolutely. Also, as far as tech events, regional events, on August 5th, which is a Tuesday, is going to be the Ohio North Database Training, and that covers a variety of topics related to database training. It's a user group held in the Cleveland area, and it's hybrid, so it's both online as well as virtual. So I urge you to check that out. And then on August 7th is going to be the Azure Cleveland User Group, and we're going to have Jeff Palermo presenting on that. We're going to have Jeff Palermo presenting on that day. On August 21st is the great, so tongue-tied today. On August 21st will be the Greater Lansing User Group meeting for .NET developers. And they have the presenter, but they don't have the topic as of yet, but that's to be announced. And then on August 27th is the Cleveland C# User Group, which is the August meeting of this group. And we don't have a speaker lined up yet, but we certainly will in time. With regards to conferences, on August 1st is Cincy Deliver. That's going to be happening in Cincinnati. And as you see, as the schedule posted here, there's a variety of different topics related to AI, DevOps, web development, and a variety of other topics. The cost for that, I believe, is $99, if I'm not mistaken. We'll go ahead and click on tickets, and you see the price ranges from $55 to $95. That's going to be held this coming Friday from 7 a.m. to 6 p.m. in Cincinnati, Ohio. In addition, on August 13th through the 15th is KCDC, which is the Kansas City Developers Conference. And as you can see here, there's a variety of topics that are going to be on the schedule regarding architecture, AI and data science, cloud, security, testing, et cetera, et cetera. So you can check that out at kcdc.info. Again, these links are all posted on my blog, so if you go there, you can get links to all those user groups as well as conferences. Another thing I always like to discuss are jobs. So like to find out who's hiring and who's looking for work. If you would please make yourself known if you're either in the job market or if you're looking for someone to join your team. You can either speak up verbally or enter into chat. And in addition, if you are in the job market, I invite you to reach out to Chris Libertine. He works for Genesis 10. He is a very reputable recruiter that I have worked with for many years. He's now working for Genesis 10, as I had mentioned, and you can reach out to him on linkedin.com. Also, another great resource is devitjobs.com. That is a site that allows you to filter on the technology, the region, whether you're going to be working remotely or in person, and a variety of other filters. So feel free to check that out, devitjobs.com. Lastly, if there's any questions I can answer for you, feel free to reach out to me, snasser@nistechnologies.com. You can also find all my socials on Linktree. And last but not least, if we're not connected on LinkedIn, let's do so. It's a great platform for connecting with peers, looking at posts, and sharing information with others. So I invite you to connect with me on LinkedIn. And with that, thanks again to Tim, and thank you all for attending, and look forward to seeing you all next month. Good night, everyone.
Good night.
Thank you.
Thank you.
This conference is no longer being recorded.
All right, now we can
Real
speak freely.
quick, real quick before I drop off, I was wondering something. I am looking for work myself, but it's been a while and I don't have any portfolio projects up that can really showcase anything yet. I'm working on a couple things, but they're not really fully formed yet. Is there any way to certifications at all? Not any old certification, I mean the official certifications that Microsoft gives.
Is that a question for me or for Tim?
Anyone, really.
Tim, you wanna jump in?
Certification in what? Are you talking about in C# or in Azure?
Yeah, C#. Oh, well, both C# and Azure.
They do provide some certifications in Azure. They dropped their C# certifications probably 8-10 years ago or so. So it's kind of you're not going to find great certifications in C# right now, at least not from Microsoft. There are some places that will offer some type of certification. But again, Azure, they do have I think you're looking up, Sam. There's stuff on Azure if you want to go the Azure route. But yeah, as far as your portfolio goes, certifications are great in some respects because they do show that you've done something. But really, what an employer is ultimately looking for is, can you do the job? That's the big thing you need to communicate is, I can do the job. And so certifications, some employers are going to love them, some are going to hate them. When it comes to portfolios, some are going to look at the portfolio, some won't. I'm actually teaching a Get Hired workshop right now. And that's one of the things we're focusing in on is how to clean up your resume. And a couple of quick tips on that. Focus on making your resume not an autobiography about what you are, who you are, but more about what you can do for the employer, what you've done for past employers, what you can do for the upcoming employer. And then when it comes to adding new skills, learn something and then build something with it. Show you have at least some experience. You can do the job. Keep it real small. You don't have to have portfolio items that have 100,000 lines of code. You can create small portfolio items that just show, hey, I can do this, but just try and go beyond the hello world and show you can accomplish something with the thing they're looking for.
I think I got similar advice in the past, but I keep getting stuck on the concept that the portfolio projects have to at least be different from what someone could do if they just followed a YouTube tutorial. You know what I mean? That's been my main concern, and I've had kind of like a writer's block in that fashion where, okay, what innovation can I make to, like, say, a to-do app that would make it, palatable, or an inventory app that would make it pop to an employer. I don't, make it pop, and maybe I don't need to overthink it that much. So
yeah, there's a balance there, right? Like you definitely don't want to have a copy paste of somebody else's work because that's not, I have a number of full projects on YouTube where we build a full app. And if you were to take the source code from that and just show an employer, well, if the employer knows that I was the one that created it, now you look like you're just passing somebody else's work off as your own. And that's what you want to avoid, what you're saying. But you don't have to go full in depth. What I like to do is see if you can solve a small problem. You're not trying to innovate and create like this thing that no one's ever done, because how many lineup business apps are out there? A bajillion and one. But instead, you're trying to solve a problem. For example, I'm building an app right now that is a Blazor WebAssembly app that would be essentially a to-do list. But instead, it's a grocery app. And it's a grocery app for my family. We have 6 people that live at my house. We have my in-laws live with us, my wife and myself, and then my 2 grown sons. So there's 6 of us that put things in the grocery list. And we never know who put that on the list. Why is it on the list? What if we already have it on the list? Did you mean to put the extra thing on the list? All that stuff that goes with it. So what we do is I'm creating an app that would just say, hey, my son John added this to the list. My mother-in-law added this to the list. And then what it was in the quantity. And then when we go to order groceries, we can look at the list and say, okay, here's all the things. And if we have any questions, we know who added to the list. We can talk to that person. It's a to-do list. It's all it is. But what it does is it solves a problem that a simple to-do list doesn't solve. So it's still tiny, and yet it's actually a functional application that solves a problem. I have another one that I'll probably turn into a portfolio item as an example. That is, I call it Simple Image Viewer. When I do my YouTube videos, I have a slide at the beginning, and then I go right into code. Well, I was doing that in PowerPoint. You got to create a new PowerPoint thing every time, and you got to do the presenter view, and then you got to hit escape, and then you got to go back over to Visual Studio, and just causing a pain. So I created a small WPF application that was headless. It had no border, nothing. And when I right click on a folder inside of Windows Explorer, it will open up or load all the images from that folder into a carousel. And if I hit the next arrow, it shows the next image, and so on, and I can full screen it. So then I just show that instead. Well, that's a little thing that solved the problem that I have that I could show off if I was demonstrating my WPF skills. So just choose tiny little things that solve little problems, create a portfolio item out of it. The real thing that you want to show off is that you can write code that an employer can then look at and say, I want them doing that for me. So the closer you can get to whatever you're applying to, the better. So if you're applying to, let's say, create front-end website for small businesses, then I'd create a front-end for a small business and show off that, hey, I can do this. And they go, oh, I'd like to have that for my own business. If you want to work on line of business applications for companies, create a small line of business application that the employer can go, ooh, I can see how that would be useful.
Oh, thanks. Yeah, that does put it a lot more. It does add a lot more context. Okay. Yeah, the shopping thing sounds interesting. I'm pretty sure there are people who've been slapped asleep at shopping places who hate shopping less than me still. But so that is one of the things I'm looking at, trying to find. Oh, what's something I can make for shopping that will make me hate it less, that isn't just a shopping list.
Sure.
But I wouldn't have thought of that because it's just me buying the stuff. So it's not like it's a big need to say who it came from.
But I've done this before. You use the last of the milk of the fridge and you forget to put it on a list, and then you go to this, you go use something that needs milk and you're like, oh no, and it's too late because the store's closed. This is where, having a little list that you put things on, and you could have quantity and you can take a picture of it so you know which milk to get. There's lots of little things you could do to innovate beyond just the to-do list that would be solve a little problem. Doesn't have to solve your problem, but it's usually best to solve your problems because of the fact that the spurs that you kind of grind against when you use anybody else's app. And you're like, I'm going to solve this one little problem. And it shows that you're not just creating a demo of somebody else's, a copy of somebody else's work, but you're creating something that actually works. And yet it can be 100 lines of code. It can be 500 lines of code. It doesn't have to be huge.
Okay.
The one thing I would also like to stress is I think it would be better to create multiple small projects as opposed to one big one, because this allows you to dabble in various technologies. Also, make sure that with each project you have unit tests that are incorporated, because a lot of employers look at that. That, as a matter of fact, that's usually one of the working interview questions is, can you write unit tests? And they actually have you do it. And as far as certification goes, pursue it, but don't live and die by it. And here's why. Not every employer is going to recognize that. Some will give you a pat on the back. Others will say, we really don't care one way or the other. The ones that do care are the ones that are Microsoft partners. This way they can say, we have X number of employees with X number of certifications. So that's where it really applies. But it really is never a make it or break it. But I still am a strong advocate for getting certified, because it exposes you to a lot of things that you may not otherwise get exposed to, as far as learning
Yeah.
the various technologies. And having an additional certification never hurts. No one ever says we're not going to hire you because you're certified. It's either going to help you a little bit or not so much, but it definitely cannot hurt you.
Yeah, the main reason I was aiming at getting one is for the learning plan more than the actual, I just wanted one that is worth, because obviously if it's worth something, if it's adding to your value for an employer, at least a little bit, then obviously it's worth learning. There's a lot of certifications out there that are probably, I don't know, I've never really done one, so I don't know if it's worth learning or not. So yeah, that's where
I will tell you, it can be frustrating. My first certification test that I took back in, 2005. I failed it twice before passing it the third time, but I was determined to get it. And then after that, I kind of got the hang of it and was able to nail them. My last exam was this past March, and the stuff that I studied and the stuff that they had on Microsoft's website was a far departure from what they actually had on the exam. The questions were much more complicated on the exam, so it kind of forced you to know your stuff. But I just wish they reflected some of that complexity in the practice exams.
okay.
Does that help, Daniel?
Yes.
All right, very good. If you have any questions, feel free to reach out to me. You got my contact info. And best of luck with the job search.
Thank you.
All
And thank
right.
you, Tim, for answering questions too, and for
Of
the
course.
whole talk. Like I was darting back and forth making calzone, but I heard it in the background when I wasn't sitting down too. So
Nice.
All right, very good. Thanks again, Tim, and have a good night, everyone.
All right. Thank you.
all right,
Okay,
Bye.
bye.
all right.